Ferrari's 2026 development program is quietly revealing something far bigger than a normal regulation change response. Deep inside Maranello, an aggressive weight reduction philosophy is taking shape, and it is being driven by a source most Formula One fans would never expect. Rather than relying purely on traditional F1 research, Ferrari has begun building its next-generation car using engineering methods and performance logic learned directly from its Le Mans hypercar program. What appears on the surface to be a simple design update is, in reality, a fundamental technical shift that could reshape how Ferrari competes in the new hybrid era. The roots of this philosophy come from the Ferrari 499P, the hypercar that returned Ferrari to the top of endurance racing and delivered a historic Le Mans victory. Engineers who worked on that program were forced to solve an extremely similar problem to the one Formula One now faces. They had to maximize electric power output, manage growing battery weight, and maintain aerodynamic efficiency within strict regulations. That program produced more than trophies. It produced engineering habits, development strategies, and problem-solving systems that Ferrari is now feeding directly into the 2026 Formula One project known internally as the 678. One of Ferrari's greatest advantages lies in the way it builds its cars. Unlike customer teams, Ferrari designs and produces almost everything under one roof. The engine, gearbox, chassis, electronics, cooling systems, and suspension are all developed inside Maranello. That allows departments to work in parallel rather than in sequence. When power unit engineers discover a packaging limitation, they do not need to negotiate with an outside supplier. They simply walk to another department and redesign the entire architecture around that limitation. This internal ecosystem is now being used to attack weight distribution at a system level rather than treating each component in isolation. The transmission has become one of the primary focus areas. In modern Formula One cars, the gearbox sits behind the power unit and carries enormous structural responsibility. It is also one of the heaviest components on the entire car, second only to the power unit and battery system. Ferrari engineers have not simply tried to shave grams off individual gearbox parts. Instead, they have rethought the entire gearbox casing philosophy. The goal is to make the transmission significantly more compact, even if that means redesigning multiple internal components. This compact gearbox allows Ferrari to dramatically tighten the rear bodywork. When the rear end becomes narrower, it immediately benefits the diffuser and the underfloor. Cleaner airflow enters the diffuser, allowing it to generate stronger and more stable downforce. Drag is reduced at the same time. This is one of those changes that delivers multiple performance gains from a single packaging decision. The car becomes faster in a straight line, more stable through high-speed corners, and more predictable for the driver under braking. But the benefits do not stop with aerodynamics. A smaller transmission also allows Ferrari to reposition heavy components closer to the center of the car. This improves the center of gravity and makes weight transfer more consistent under cornering loads. That means the tires work more evenly across their contact patches, improving grip, reducing degradation, and giving drivers more confidence over a race stint. Where Ferrari faces its greatest challenge is the battery system. The 2026 regulations will massively increase the electric contribution of the hybrid system. Electrical power output will rise from roughly 120 kilowatts to 350 kilowatts, almost tripling the importance of the battery pack. More electric power normally means larger battery capacity, and larger battery capacity usually means additional weight. That is the trap many teams now face. Ferrari is attacking this challenge with experience gained from the 499P hypercar program. In endurance racing, battery efficiency and thermal stability are critical for long stints at maximum performance. Engineers working on that program spent years developing cooling strategies, packaging layouts, and power electronics integration methods that balanced weight, reliability, and output. While Formula One regulations are different, the mental framework and development discipline built in that environment is directly transferable. Ferrari has not copied the 499P battery. Instead, it has copied the way the 499P team approached optimization. Engineers understand how to minimize wasted mass, how to integrate cooling channels directly into structural battery housings, and how to package electronics in ways that shorten cable lengths and reduce electrical losses. These ideas are now being embedded into the 678's battery design, allowing Ferrari to increase electrical output while keeping total mass under control. Another decision that initially caused controversy is Ferrari's use of a steel alloy cylinder head for the 2026 power unit. Steel is heavier than aluminum, and at first glance it appears to contradict a weight-saving philosophy. However, Ferrari is manufacturing these components using advanced metal additive manufacturing techniques. This allows engineers to vary wall thickness at microscopic levels, remove unnecessary material from internal passages, and design cooling channels that cannot be produced using conventional machining or casting. The result is a cylinder head that may be made from heavier material, but which carries significantly less total mass than a traditionally manufactured aluminum head. More importantly, steel offers superior thermal stability. This allows Ferrari to run smaller radiators and reduce cooling mass across the car. That reduction in cooling system weight offsets any remaining material penalty while also improving aerodynamic packaging. Because Ferrari designs the power unit and chassis together, these cooling benefits can be exploited more aggressively. Smaller radiators allow the side pods to be sculpted more tightly, creating stronger outwash and better airflow control around the rear of the car. A narrower rear end feeds a cleaner airflow into the diffuser, increasing underfloor downforce and reducing drag. Each packaging gain multiplies the benefit of the others. Ferrari has also redesigned the suspension architecture for 2026. The team is moving to a pushrod layout at both the front and rear, abandoning the pull rod concept used on the current SF25. This decision is not purely aerodynamic. It is driven by tire management priorities under the new regulations. Technical Director Loic Serra, who joined Ferrari after years as a vehicle dynamics specialist, has placed heavy emphasis on understanding how tires generate grip under different load and temperature conditions. Ferrari has been analyzing data from its revised rear suspension package that debuted at Spa. Those findings have shaped the development direction for the 678. The goal is to maximize the usable performance window of the Pirelli compounds, ensuring consistent grip across long stints rather than focusing solely on peak aerodynamic load. Sidepod development has also become more aggressive. Ferrari is pushing hard on outwash efficiency and radiator inlet packaging. The undercut area is expected to be particularly pronounced, allowing stronger airflow redirection around the rear tires. This further cleans up the air feeding the diffuser and underfloor. Engine cooling mass has been optimized to allow a tighter rear section, which improves straight-line speed while increasing downforce potential. The cleaner the diffuser's working area becomes, the more efficiently it can generate vertical load without excessive drag. Ferrari has now finalized the launch specification of the 678. The car is scheduled to begin its first official running at Barcelona between January 26th and 30th. This initial test will validate power unit architecture, gearbox packaging, cooling efficiency, and bodywork performance against simulation predictions. Engineers will analyze how accurately their digital models translate to real-world data. Following Barcelona, Ferrari will introduce its first development updates during the Bahrain test scheduled for February 11th to 13th and February 18th to 20th. These sessions will focus on refining aerodynamic performance and validating cooling system efficiency under higher ambient temperatures. One of the final days in Bahrain will feature the aerodynamic package intended for the Melbourne season opener, allowing Ferrari to establish a stable baseline before competitive running begins. What makes Ferrari's approach particularly powerful is the flow of knowledge between its racing programs. The 499P hypercar achieved its Le Mans victory and WEC championship success through intelligent energy deployment, careful mass management, and relentless optimization of hybrid integration. The engineers responsible for those achievements are now shaping the philosophy of Ferrari's Formula One future. This is not a simple technology transfer. It is a cultural and methodological transfer. Ferrari is applying the same problem-solving habits, development discipline, and performance logic that proved successful in endurance racing to Formula One. Engineers understand which design compromises work under race pressure and which ones fail. They know how to balance reliability with outright speed and how to manage complex hybrid systems without sacrificing aerodynamic efficiency. The result is a 2026 car built around strategic weight distribution rather than uniform weight reduction. Mass is being placed where it improves vehicle dynamics rather than simply being removed indiscriminately. Cooling systems are integrated directly into structural packaging. Gearbox architecture is designed around aerodynamic performance rather than convenience. Battery systems are optimized using endurance racing logic rather than Formula One tradition. Ferrari's single-facility development model amplifies all of these gains. While customer teams must coordinate engine integration with external suppliers, Ferrari controls everything internally. Power unit engineers, chassis designers, suspension specialists, and electronics departments can collaborate in real time. This accelerates development loops and allows continuous refinement that customer teams cannot replicate. The steel cylinder head, once controversial, now appears to be a cornerstone of a broader thermal and mass management strategy. Smaller radiators, tighter packaging, and improved airflow efficiency cascade across the entire car. Combined with the compact gearbox and optimized battery pack, Ferrari believes it can achieve a total weight figure that is not only competitive but potentially class-leading. Ferrari's approach to the 2026 regulations reflects a coherent and unified technical philosophy. Leverage vertical integration. Apply endurance racing knowledge. Optimize weight distribution strategically. Prioritize aerodynamic cleanliness through disciplined packaging. Allow thermal efficiency to drive mass reduction. Use simulation, but validate relentlessly on track. The Barcelona test will provide the first real answers. Bahrain will reveal whether Ferrari's development direction is stable. Melbourne will show whether these strategic decisions translate into competitive performance when it truly matters. Ferrari has prepared for this era with technical maturity, structural discipline, and a development philosophy shaped by success beyond Formula One. When the lights go out in 2026, Ferrari will not simply be racing a new car. It will be racing a new way of thinking, one forged at Le Mans, refined in Maranello, and now ready to challenge the future of Formula One.